well, it used to be a single page, but I added some pictures to it. So if you guys can find page 13 on pyramids for me. Okay, a lot of the vocab words on this one. Oh, you won't have to measure them on. I'll talk to you about what the quiz question will look like. So the pyramids that you guys see here are all regular pyramids in the sense that the base of the pyramid is a regular polygon. In the chat, can you guys type out some differences that you notice between a pyramid and a prism? Because the number one mistake, and actually right after we started doing classwork, a student started to make that mistake, and they both start with the P. So sometimes we confuse the two, and then if we confuse the two, we use the wrong formulas. We kind of have like the wrong idea about what we should calculate. So what are some differences you guys notice about prisms versus pyramids? And I'll name some of the stuff that you guys have mentioned here. Good. Okay, so I see everything on there that I want to see. So someone said that there's only a single base. That is true because this triangular pyramid, rectangular pyramid, and hexagonal pyramid only have a single base. Because of that, what happens is at the very top, you guys have something different than what a prism is. At the top, you guys have this point right here. If you guys can label that point a vertex, that's a new word for this because the prism didn't have a single vertex at the top. So then basically all the lateral faces meet at this vertex at the top. And then the next observation is a little bit harder to notice, but I did see someone mention it. If you guys look at the lateral faces here of all the pyramids, they are triangles. What was the lateral face of a prism? What was the lateral face of a prism? Okay, and it helps you guys to understand these differences because that's where some of the formulas come from. They just don't come out of thin air. So the lateral faces happen to be triangles. And so what I'd like us to do is just define one thing by drawing a picture. So if you guys can picture yourself, and many of us think of pyramids as the Egyptian pyramids. So imagine yourself standing at the top of the Egyptian pyramid. Go ahead and draw yourself on top of the middle pyramid. And then if you happen to be standing up there and I asked you guys, how high are you guys, or what is the altitude of that prism? And you happen to throw a rope over the side of the prism. Can you guys go ahead and draw that rope? You draw that rope down over the side of that pyramid. And I'm gonna make mine a little bit more in the middle. Okay, and then you throw it perfectly so it goes down the side, cuts across the midpoint, and this is a right angle right here. Would that be an accurate reflection of how high up you are? Yes or no, you guys? Would that be an accurate reflection? When we say that that's how tall a mountain is or how high that pyramid is or how the altitude, that's not a measure of the altitude. That's not the measure, that's not how we measure height. Okay, so in fact, notice that height is slanted. So this is actually called a slant height. So L is equal to slant height. And it does come into play for our calculations. So yes, now when we look at pyramids, we have two different types of heights. Okay, so Iman is saying the altitude is, imagine if you guys were at the top of the of this pyramid and there's a hole at the top of it where the vertex is. And then the measure of the altitude would be if you guys throw a rope down straight through the hole and to the center of the base or the square. If it's a regular pyramid, it's going to hit exactly right in the middle of the square. And so that's the measure of altitude, the true measure of height. So you guys can label that as H, which is the altitude. So please be very aware of the fact that there's two different heights in a pyramid. There's the slant height and there's the altitude. Okay, so with that, if I can have you guys tell me what is formed if I also happen to notice that since that's the middle of the square, this is the side length of the square. If you guys had to take a guess, what would the length of this piece be right here? Okay, someone is noting that that's a right angle. Yeah, so guys, that's gonna be something that you're gonna have to know is that smaller green is exactly half of this green right here, this side. Okay, those are things, assumptions you can make with all regular pyramids. Again, this side is half of the entire base side. Okay, so let's go ahead and connect that. I think someone mentioned that there's a right triangle now inside that. So if you guys were to take a knife and slice the pyramid straight down, you get what we call a cross section. That cross section is a triangle, and this triangle that you guys see right here is exactly half of that triangle. Okay, so another thing I want you guys to notice is that I'm going to highlight this triangle right here in yellow. Okay, and then look at the other triangle that is the cross section. So this triangle right here. Okay, are those two triangles equal to each other? What do you guys think? Are those two triangles equal to each other? Okay, so I haven't told you guys yet, but if you look at those two triangles now, and let me point you guys to something that might help answer this question. What do they both share? What do those both those triangles share? Like what overlapping value do they both share? They do both share a side, specifically this side here. Okay, so this side here for the yellow triangle happens to be one of the legs of the triangle. Again, the slant height is one of the legs of this yellow triangle. What is it of the cross-section triangle? What is it of the cross-section triangle? What's the slant height and how is it related to the cross-section or the cross-section triangle? Very good. It's the hypotenuse of the, so this slant height is the leg of this yellow triangle, but the hypotenuse of this triangle here. Can they be the same triangle? Okay, they cannot be the same triangle. So that's probably the biggest mistake I see with pyramids is assuming those two calculations are the same. They can't. Okay, so if this is the leg of one triangle and the hypotenuse of another triangle, it can't be the same triangle. Okay, so let's keep going here. So for every pyramid, what type of polygon was the lateral faces? We actually answered all these questions already. So the lateral faces was triangles. And if we think about how to find lateral area, it's really, you're finding the area of all of the triangles together, so a number of triangles. To help us come up with the formula, which is on the next page, how does the number of lateral faces compare with the number of sides of the bases? What do you guys think? How does the number of lateral faces compare with the number of sides of the base? So count the number of lateral faces, count the number of sides of the base. Okay, they should be equal. There is one triangle, one side, two triangles, two sides, three, and then four. So actually, as I'm doing this, you guys, what am I tracing? What is that called of the base? We did the same thing with a prism. That's the perimeter. Okay, that's the perimeter. So the perimeter happens to be the sum of all the bases of the triangles. And then the, and notice that the height of this triangle right here is the slant height itself. Okay, so how does the number, so it's the same number. Okay, below here, you guys just see two nice pictures of regular pyramids. That's a regular square pyramid and a pentagonal one. So you might ask, what does an oblique pyramid look like? It's, if you guys can watch my cursor, if I took this cursor, or sorry, I took this vertex and I moved it over to like say right here. And then I started to connect that point to all of the vertices of the square. Do you notice how by moving the vertex so it's skewed away from the center, now the altitude isn't like, when you measure it straight down, it's gonna be kind of awkward and not in the middle of the square. So this is an oblique, pyramid, and we don't work with oblique pyramids in this class. Everything is regular. Okay, on the next page. So the formula I'd like you guys to highlight comes from the picture that you guys had above. So you don't have to move anything, I'm just gonna have you guys highlight lateral area for me for a moment, and then just focus on my screen. So again, if you're looking at the area of this triangle, you would need the area of what a triangle is. So what is the area of a triangle as you guys know it? What's the area of a triangle? Okay, half base times height. So the half comes into play there. The base is this, but because you have one base here, two base here, three base here, four base here, or in other words, the perimeter. The perimeter is in the formula, and then also the height is the slant height here of this triangle. So back to the formula itself, I'm going to have you guys write this above it. This comes from the fact that you know the area of a triangle is 1/2 base times height. The base, the B, is replaced with P because you're summing up all of the triangles, which all have a common base, and the perimeter represents the sum of that. And then the L is your height of each one of the triangles. So we're going to remember as 1/2 PL. Again, you don't have to memorize it because you guys have a formula sheet eventually for it, but it's nice for you guys to know where it comes from. Okay, what's the difference between the total area formula that you guys see here and the one that you guys saw for the prism? What's the difference between this formula? Okay, there's no 2. The first mistake I saw on the homework assignment was when we switched back to prism, someone just used one base. So just kind of knowing the difference between the two, being able to picture that a prism has 2 bases. A pyramid only has 1 base. And then finally, I think you guys all did this experiment or something like this in middle school, but do you guys remember having, and I know we have the figures, if we had time, I would do it with you guys. And if we were in person, obviously, but do you guys remember filling up like a shape that was a prism versus a shape that was a pyramid with like sand or something like that, or beans or rice, and then seeing what the volume was? Does anyone remember doing that in middle school? Okay, what you should have seen with that experiment was that the pyramid held exactly a third less, or yeah, a third of the prism. So that's where this 1/3 comes from. But basically, formula is a third base times height. Okay, we're gonna do just a few problems together. Notice that none of these have pictures tied to it. So on your quiz, you're gonna get something like this, a description of what the problem is, and then asking you guys to find out and fill out the rest. Okay, so you're gonna be asked to, instructed to draw the picture or to find an object that looks like it. So a regular square pyramid has a base edge of 6 and lateral edge of 5. So we're gonna practice drawing this together. Can I have you guys draw a slanted square, which is basically a parallelogram? So you're gonna have to draw this on your own as well. Okay, over the years, I noticed the easiest way to draw this so that it looks accurate is to find the center of that square. You guys are gonna find the center of that square. And then go ahead and draw the altitude going up from that. So this is drawing something that's three-dimensional. Okay, from the vertex at the top, what you guys are gonna do is extend out to each one of the vertices on the square. So this side is kind of tricky because it's like almost the same thing. And yours might look like the same side. That's okay. Okay, so from the top, you guys are gonna connect it to each one of the points on the square. And there's your pyramid. Okay, so we're gonna add a couple of things to this picture. You guys are gonna add the slant height to it. And if you want, some people just start to sketch out the cross-section triangle if you want on there, and then start to label things. Okay, the base edge is 6 centimeters. So when I go to label this base edge right here is 6 centimeters. And then when they describe the lateral edge, that's not always given to you guys, but the lateral edge is the intersection of the 2 lateral faces. So if you look, what those 4 lines that you guys just drew, those are the lateral edges. So what I'm gonna do is label one of them 5. the first thing they asked us to calculate is slant height. You always need slant height in your calculation. So if it's not given to you, it's something that you guys have to find. So what I'm going to do is highlight this triangle in yellow right here. That's part of one of the lateral faces, and it has a slant height in it. I'm going to draw that triangle. If you guys have colors, it might be useful for you guys to break it out so that you can color code the two triangles. Okay, so you've got that according to what I've labeled, this is 5. Good, Cody, that is right. Okay, this, what can you guys assume this is equal to in green? What's that equal to? Okay, so it's exactly half the base, so that's 3. And someone in the last class said, Mrs. Kim, is that a 3, 4, 5 triangle? So I don't know if we talked too much about Pythagorean triples, but 3, 4, 5 is what we call a Pythagorean triple. It's just basically if you guys do Pythagorean theorem enough, you'll notice that that's a common one. If the hypotenuse is 5, the other two sides must be 3 and 4, or 3, 4 for the legs, and then the hypotenuse is 5. Again, if you applied Pythagorean theorem, it'd be 5 squared minus 3 squared, which is 16. Square root of 16 is 4. I don't know if you guys know this rule, but if you don't have to write this part of it out, but if you guys were to multiply, let's say by a common factor for all of these sides, like 6, but if I multiplied by 2, I'd get a 6, 8, 10 triangle, which is also a Pythagorean triple. If you guys then multiply by a common factor like 3, 3, and 3, a 9, 12, 15 is also a Pythagorean triple. So multiples of 3, 4, 5 are also nice triangles with Pythagorean triple values. So the slant height here is equal to 4. Okay, so when we're calculating lateral area, okay, your lateral area is 1/2, think of like a triangle's 1/2 base times height, but the base is the perimeter and the height is the slant height. So if you guys plug it in, we have 1/2. Can you guys type in what is the perimeter of this pyramid? What is the perimeter that they're talking about? Okay. Good. I think someone in the last class put 36, but maybe we were thinking hexagon, 6 times 6. This is 4-sided figure with a square. So 4 times 6 is 24. And then the slant height itself is 4. If you guys can make sure you look up for this calculation on the chapter 11 quiz, I had a number of people do half of, in simplifying something like this, they did half of 24 is 12, and then they did half of 4. It's not distributive property. So when you guys take a half of 24, you've already like used your half of. So that's like 12 that's left, that then you multiply by 4. Okay, so half of 12 is, or half of 24 is 12, 12 times 4 is 48. 48 is the correct calculation for lateral area, and this would be square units, so meters squared. All right, you guys, go ahead and calculate the base area and then the total area for me. Just think total areas, you add up everything, right? You add up all your area. And then type in what you guys get for total area. Okay, good. Okay, base area is side squared, so side is 6. You guys should have gotten 36 meters squared for that. Double check when you guys added it. Saw one person enter 72. If you add lateral area plus base area, you guys get total area. Remember, there's only a single base, so no need to double the base. It's just a single base. So it should be just 84. Just adding lateral area plus the area of the base is 84 meters squared. Okay, so then the next thing we're gonna do, if you guys have a different color highlighter, go ahead and highlight now the other triangle, the cross-section triangle, this one. Whoops. Okay, so that triangle right there is the one that you would get if you guys sliced it. And here we have that this is a right triangle. Okay, we know that the slant height is 4. We calculated that. And then if you guys can tell me what is the measurement of this side, of this leg that's green here? What's the measurement of that green leg? Okay, exactly. Since it cut down the center of your square, then it should be exactly half of this square length, which is 3. So very good, 3. Here's a question, you guys. Is this a 3, 4, 5 triangle? Can this be a 3, 4, 5 triangle? Okay, it can't because the leg can't be bigger than the hypotenuse. So it can't be 3, 4, 5. Can you guys calculate then what the height is equal to? Okay, good. Getting so much faster at our radicals, right? So 16 minus 9 is 7. So square root of 7. Very good. So square root of 7 is the length of our altitude. Square root of 7. Meters is the unit. Meters is the unit of measure for all things that are just measuring a length. So square root of 7 meters. And then we're at our final calculation, volume. Since this is a pyramid, we're going to do base times height, a third of that. So the base area was 36, and then our height is radical 7. So again, when you guys are calculating this, you can do a third of 36 is 12, and then just put the 12 in front of radical 7. So 12 rad 7 meters cubed. Okay, so something like that would be similar to what you guys would have on your quiz. Number 2, you have a regular triangular pyramid, has a slant height of 9 centimeters and a base perimeter of 12. This one's not asking us to calculate everything, but let's practice drawing this. The triangular pyramid being regular means that it has a equilateral triangle. So go ahead and draw like that's a poor equilateral triangle, kind of like a slanted equilateral triangle for me. Find the center of that to then draw the altitude. I think that triangular pyramids are trickier to draw, mainly because when you guys start to connect it to the vertices, it just starts to overlap your altitude a little bit here. Whoops, I tried to go around it so you guys could still see the altitude. But that's your triangular pyramid. Not very good. It looks like a kite to me now. Okay, so you guys have that you're given the slant height this time, which I'm going to do in red. The slant height is from the top, technically forming a right angle there, and that is equal to 9. They gave you guys that the base perimeter is 12. So if the base perimeter is 12, what is the length of each one of the sides? Okay, there's 3 sides, so 4. Very good. And then if I go back to my lateral area, just to find what the calculation is for that, I know that lateral area is triangles here. So 1/2 base times height, but the base is the sum of all the bases, which is perimeter. And then the height of each one of the triangles is the is the slant height, so L. Okay, we have the perimeter and we have the slant height. So actually, they gave me all the information I needed for this problem. So in this case, we have perimeter is 12, slant height is 9. That was in the given information. When I multiply 3 numbers together, I'm not going to do distributive property. I'm just going to do half of 12 first, which is 6, and then 6 times 9, which is 54. So it being area, we are going to do centimeters squared here. Okay, the area of the base is the area of an equilateral triangle. How many of you guys remember that an equilateral triangle's formula is radical 3 over 4s squared? I saw that a lot of us use that on the quiz, which is what I would default to. If I already have the side length is 4, that to me is the easiest way to calculate this, is just taking the side and squaring it. So let me just show you guys where quite a few of you guys stopped. So you plugged side in and you didn't know how to simplify it from there. You just kind of left your answer like that. Okay, so when you guys are doing this calculation, simplifying this, the 4 squared goes on top, technically in front of the radical 3. So 4 squared is 16. So in theory, it's 16 rad 3 over 4. Now, if the 4 and the 16 can be reduced and they're outside, then you would go ahead and reduce that. So 4 goes into 16 4 times. So 4 radical 3 is the base area, so centimeters squared. Total area, again, don't double the base. This time you guys just add the two areas together, that of your lateral area and a single base. So 4 radical 3, and then this is all centimeters squared. Okay, our very last question, you guys. Can I have you guys try to draw, see if you guys can draw a better triangular pyramid again down below here? Trying to figure out what went wrong with my triangular pyramid. I think if you put it in the center, you can't see the side. So that's why I was trying to like slant it a little bit. Or maybe it's too much like an equilateral triangle. Maybe you want it to sit down so it's skewed a little bit. Okay, so for this one, they tell you that the height of the regular triangular pyramid is 6 centimeters. So inside here, I'm gonna make that height red. That's inside, we drop the rope. Inside the height is 6. The radius of the base is 8 centimeters. A couple of us in the middle of the chapter 11 test direct messaged me, Mrs. Kim, did you make a mistake on the quiz? Why did you say radius of a square or radius of a triangle? That wasn't a mistake. That was when we did regular polygons and we said equilateral triangles and squares are polygons. So what we're gonna do is draw the base larger over on this side. This is the base being an equilateral triangle. And let's draw what the radius is. If you guys put the, when they're talking about the radius of a shape like a triangle, you're gonna picture there's a circle. You don't have to draw the circle around it, but technically there's a circle that it's circumscribed within. And when you think about the radius of a circle, it's from the center to the edge of a circle. So that happens to be on a regular polygon. The radius is from the center to one of the vertices. So that's a radius. Okay, then we're gonna work with the radius because that's what they gave us. And that was 8 centimeters long. And then now we gotta build our triangles. So here we know 360 divided by 3 is 120. So if I'm looking at the triangle that's built here, just enlarge it over here, the top angle is 120. So then dropping that apothem is gonna make this 60 degrees. Let me enlarge it here for you guys. We know that the hypotenuse of that is 8. Okay, the apothem is therefore across from 30 degrees. It's 4. What's this side length equal to? Or what's that piece equal to? Okay, 4 square root of 3. I'm still having some kids, I think, not memorize those 30, 60, 90, 45, 45, 90. I almost want to say, you guys, the whole trig stuff, all this trig stuff you guys learn next year, it's all built on these 30, 60, 90 triangle values and 45, 45, 90 triangle values. So you have to know it. There's just no way you can get through trig unless you guys know those values. So 4 rad 3. And then this whole entire side length here is 8 rad 3 because we double that. And so just to show you guys the calculation of the area of using the formula that we just discussed, at this point, you guys have 2 routes to go. You can just do 1/2 AP and go the route of the regular polygon, or you guys can just go, I know what the side length is. I'm just going to use rad 3 over 4 side squared to find the area of the base. I wanted to do this one just to show you guys how to simplify the base, or sorry, how to simplify the radical. So 8 radical 3 squared Okay, you guys, remember when you square something with a coefficient in front of the radical that you're squaring the 8 and you're squaring the radical 3. So if you square the 8, you guys get 64. So you got radical 3 over 4 times 64. And then times radical 3 squared is just 3. Okay, you guys can simplify this because 4 goes into 64 16 times. And then 16 times 3 is the number that you would put in front of radical 3. So 48 radical 3 is the answer to the area of the base. And that is centimeters squared. Okay, we're going to finish off our problem with the other value that they asked, which is finding the volume. This is a pyramid. It holds a third less than a prism. So 1/3 base times height, 1/3. The base was 48 rad 3. The height was provided to me. I believe it was 6. Yeah, they tell me it's equal to 6. And again, it's multiplication. So you guys can do a third of either 48 or 6, not both, right? So a third of 6 is 2. So you guys can simplify that part first. 3 into 6 is 2. And then double 48 to get 96. Radical 3. So don't take a third of both. So 96 radical 3 centimeters cubed. And those are your two solutions, this one and this one. What I'd like you guys to do just to practice how the quiz format is going to be is